All right. When you are trying to calculate the relative humidity, what that means is you're trying to find two values so you can make a comparison. Okay, what are those two values? All right, the relative humidity, okay, is expressed most of the time as a percentage. Okay, and it's a percentage of two things. One called the AH, absolute humidity, okay, divided by what we call maximum content. Okay, so what is absolute humidity really in kind of real terms? It's how much water is in the air. Okay, and what is the maximum content? It's how much water can be in the air, which is a maximum amount. Okay, so if I know two things, how much water is in the air, I know how much water can be in the air, I can calculate the relative humidity. Now, to get this, I have to make two measurements. First measurement, the air temperature. Okay, and let's just say as an example that the room is pretty warm, and so I'm going to say it is 70 degrees Fahrenheit, not Celsius, 70 degrees Fahrenheit, or on our chart, that's 21 degrees Celsius. We can use either, but they both have to be the same in terms of measurements. All right, and so how in the world do I find how much water is actually in the air? Well, this is where we get a dew point. What we're going to do is we're going to cool down the air until water falls out. Okay, and we see that in terms of condensation. And so what would happen if by chance we would get a dew point of, let's say, 55 degrees Fahrenheit, or on the chart that we're going to use, 55 is equal to 13 degrees Celsius. All right, now how did I get those numbers? You're going to have a glass. It's going to have water in it. And you're going to put pieces of ice in the water glass. Now, before you put the piece of ice, you're going to take your thermometer and you're going to read the temperature of the air. So that's the first. So this would be where we read 70 degrees or 21 degrees Celsius. Then you're going to put your thermometer in and you're going to stir up this glass. Now what's going to happen is the water's going to cool down and the side of the glass is going to cool down and the air right next to the glass is going to cool down. And as it gets cooler and cooler and cooler, what's eventually going to happen is you're going to start to have some condensation build on the glass. As soon as condensation starts, that is when you take the temperature, and the temperature is going to be the dew point temperature. And then in our example, it was 55 degrees Fahrenheit or 13 degrees Celsius. Okay, so I have two temperatures. Now, what you're going to do is you're going to need to go to the lab and look at the lab, and we're going to find two values. Okay, the value for 13 is 4.8 And that is measured in what's called grains per cubic foot. Now we could measure pounds per cubic foot of water or grams per cubic foot of water. We're going to use a term called grain, and it's 4.8 grains. The other measurement that we took was 70 degrees Fahrenheit or 21 degrees Celsius, and the value there is 8. So we're going to have a value of 4.8 and we're going to have a value of 8. 8 is the amount of water that can be maximally held in your air under this example. And so the maximum content coming from the 70 degrees Fahrenheit is a maximum of 8 grains per cubic foot. The absolute humidity, or what's actually in the air, is going to be 4.8. And if I want to change this into a percentage, I'm going to have to multiply it by 100. And so it is almost or very similar to a grade. The highest grade you could make right now is an 8, and what the air got was a 4.8 out of 8. So I take 4.8 divided by 8 times 100. It would be a 60% relative humidity. That means the air can hold up to 100% of water, and you've filled it 60% of the way. Now, the principle here is hot air can hold more water. Cool air holds less water. And so the relative humidity is always based upon what the temperature of the air is at the beginning versus when the air actually cools down enough such that the water will fall out and condensate or create condensation on the glass. And that's what you're looking for.